In this series, we're going to show you how to take your component and pull off the wireframe abstracted geometries that we've worked through, and then associate this into Grasshopper. So considering that you have your component in Rhino, I've asked you guys to pretty much develop some kind of vertice and line type geometry that goes along with this. So for this one, it's a pyramid off of these 3 points with the top of the pyramid at the center point of our component. So to call up Grasshopper, type Grasshopper into your command line, and it should be prompted in. What we're going to do to begin is just associate these points in Grasshopper. So I'm going to pull on 4-point containers. My center point, leg 1, leg 2, and leg 3. Just to begin, because this might get complicated for some of you guys, I'm going to group them individually and then give them a name. So if I select this, hit Control G, right click in the yellow area, there'll be a box up here where I can write in that name. I'm just going to call this one center point. And then I will do the same for this. Call it leg 1. Okay, so then we have some idea of the points. To associate these guys, right click on it, set 1 point, and I'll select my center point. And then I'll do the same for the legs. And you'll see all of your points once they're selected. Within Grasshopper they'll be gray, and in your Rhino space they'll be red. So then we can hide all of our geometry in Rhino so that we just have these 3 points existing in space. So the next thing I've asked you guys to do, just to get some concepts of how to link up items, was to bring a line onto your canvas. And what this component asks for is to create a line between 2 points. So the A is the start point and the B is the end point. For ours, we can do a start point from the center to each leg, and then we want to do one around the perimeter of the pyramid. So one way to do this is to link up each one of these based off the center point. And I'm just hitting Control C, Control V to copy this component. So these first 3 then provide us with those three diagonals. Now if we want to link up the 3 at the bottom, we can just take this, and I think, no, it will not let us. For this one, when I tried to fit in all 3 points to make it go in a circular fashion, it's going to eliminate it because the start and end can't be the same. So bring in polyline. And with this, it just asks for a series of vertices as a list, so it can be any number of them. And then it's going to also provide you the option of to make it closed or not. We could have done was to make each one of these faces, these lines here, as a polyline, and then say close it, and then it would have closed along these edges. But for now, we're just going to create 2 series of lines so you guys get the idea of when to use a polyline and when to use a line. And then it needs to close back onto you. And I think the way that you select these matters. So let me redo this again. If I have, this is the starting vertex, and I go to that leg, and then to that leg. No. Alright, well then for now I'll show you how to use the closed option then. So if you bring on a Boolean, well actually if you right click on your closed or your Boolean function, it'll say set Boolean. If you make it to true, it will then close that curve for us. So now we have a closed polyline curve. What the problem is that it's going from this point to this point and this point to that point, so it's only making 3. I need to have it to go back between it, but because I have all 3 points feeding into the vertices, the order in which I'm selecting them isn't allowing it to be closed right now. In class, I think we dealt with this a little bit more seamlessly and it was closed. But now you know the other option of if you make this a true Boolean statement, it will be closed. So with these geometries, the next thing that I asked you guys to do was to group them together into one component called geometry. What this will do is, because we have a different of an output right here, we have line segments and then we also have a polyline that's a curve. So when we were discussing this in class, these will have no degree of curvature and then this one can have some degree of curvature built into it, as also a different number of control points. So if we wanted to treat our geometry as one collective unit, the way to get around this is to put it into one container. And so when we select this, you can see that everything within our Grasshopper space is green, and then we can perform actions to all of these lines regardless of their type. For here, we're just going to pause and then I'll show you how to make some surfaces based off of these lines next.